Hello and welcome to our discussion for today. And that is, we will be discussing the different mechanisms by which the healing, the healing and repair of damaged tissue takes place. We have a normal tissue that undergoes damage. That damage depends on the extent. There is a damage that penetrates deeper than the epithelium, and we go to the underlying tissue. So the epithelium is the frontier and the first line of cells. And we have two types of injury: a type of injury that is limited at the epithelium, and we have also another type of injury that penetrate deeper, that engulfs and damages the epithelium, the epithelium line, and goes deeper to the underlying, or the deeper to the post, or the underlying tissue. So this is the underlying tissue, and that's the epithelium. We have an injury that is limited at that that epithelium strata, at this epithelium layer, and then we have an injury that goes deeper into the underlying tissue. So these two types of injury heal by two different mechanisms, and these are regeneration, healing by regeneration, if our injury is localized and limited to the epithelium layer. And then the other type of healing or repair is the healing by fibrosis, and that only takes place if the damage is so severe that goes beyond the epithelium layer and goes into the underlying tissue. We will also talk about the steps that take place in the case of scar formation, where we have healing by fibrosis. We have a damage that is so severe that it goes beyond the epithelium layer into the underlying tissue, and then we would have inflammation, and we first would have hemostatic plug to stabilize the blood loss. Then we will have inflammation, and then after the inflammation we will have the deposition of fibers, and we will have a mixture of epithelial proliferation, and we will also have scar deposition, and in the end we will have remodeling, where enzymes like metalloproteases would come and degrade the connective tissue in the underlying layer, and make sure to replace the collagen that is a type 3 with a more tensile and more resilient type of collagen that is collagen type 1. So this is the topic of our discussion today. These are the two objectives of our discussion today. What are the types of healing that we're dealing with, and what are the steps, the steps that are crucial in healing by fibrosis. Healing by regeneration is very simple. It's just the reproliferation of these epithelial cells that were injured, where we would have cells that are surrounding the site of the injury would proliferate and would just make up for the loss that took place. However, what needs to be studied in more detail, and what is a little bit more complicated than healing by regeneration, it is actually the process of scar tissue formation, or healing by fibrosis. So before we go into detail, let's recap real quick and see where are we what are the events that led to where we are right now, and that is the processes of repair and healing, whether healing by regeneration or healing by fibrosis. What are the steps that led to that? So recapping real quick, we said we have a normal healthy tissue comprised of normal healthy cells. These healthy cells are in a state of homeostasis and steady state, where they are constantly subjected to stressful and noxious stimuli such as ultraviolet radiation, such as infections, whether bacterial, viral, fungal, and parasitic infections. We have the cell may undergo a physical agent stress, such as a severe increase in temperature or a severe decrease in temperature. That is a form of stressful, noxious agent. We also have chemical agents such as these corrosive agents. We have traumas like burns, or maybe that damage that destroys the structure and then the tensile integrity of the tissue and the cells. Okay, the cell is equipped with built-in systems to counter all of these stressful stimuli and overcome them and achieve resolution. However, if the stressful stimuli, all of these stressful stimuli we talked about, if they come all at once at the tissue, or maybe we have the intensity is severe of these stressful stimuli. Their intensity is just so severe, or maybe the duration where these stressful stimuli was applied to the cell was just very long in duration. What happens is the cell will now become overwhelmed, and when the cell is overwhelmed, it becomes damaged. And we have two kinds of damages based on whether the cell can reverse that damage. We have reversible injury and we have irreversible injury. Reversible injury, we still have hope of returning back to normal tissue, normal health. But irreversible injury means the cell is damaged beyond salvage. And when the cell is injured irreversibly or damaged beyond salvage, we will have cell death. And in cell death, the cell would die, and cell death is by two mechanisms. There is apoptotic cell death, where the cell would die in a way that does not trigger inflammation. The cell would contain itself and get rid of itself and dispose of itself properly. And then we have necrotic cell death, where the cell membrane fragments and the intercellular content, including these lysosomal enzymes, would leak out to the tissue and cause damage and elicit inflammation. So necrotic cell death would lead to acute inflammation. If we have acute inflammation, then we have in the tissue resident sentinel cells, such as mast cells and dendritic cells, and resident macrophages, depending on the tissue. In the liver, we have Kupffer cells. In the nervous system, we have the microglia. In the spleen and lymph nodes, we have the sinus histocytes. And what else do we have? Kupffer cells, microglia, sinus histocytes, and what are the fourth type of resident macrophages? Macroglia, sinus histocytes, Kupffer cells, alveolar macrophages in the respiratory system. So these are the four types of resident macrophages that detect necrotic debris or attack by infective microbes. and they detect them with receptors that detect lipopolysaccharides or glycoproteins that are unique to these invading microbes, these bacteria, viruses, parasites, and fungi. Then these resident sentinel macrophages would send cytokines to the bloodstream, to the endothelium, to the circulation. These cytokines would first bind to the endothelium. The endothelium is not a plastic hose. It's actually living cells. The endothelium is comprised of living cells, and it's three different layers. We have the tunica, lamina, tunica media, and the tunica intima. And then this endothelium would now begin, after responding and detecting the cytokines with their receptors that are released by the macrophages, they would do retraction to create interendothelial gaps. And then these cytokines are not just targeting the endothelium, they also target circulating immune cells like polymorphonuclear cells, these neutrophils, and also the monocytes, which are the premature macrophages. And then once these cytokines released by sentinel macrophages are released into the bloodstream, what happens is they are detected by the monocytes, leading to the monocytes differentiating into macrophages, and the polymorphonuclear cells differentiating or arriving at the site of the inflammation. And they would leak through these interendothelial gaps, and they would start gravitating after following the chemokines released from the site of the inflammation and arrive at the site of the inflammation. Then we would have a battle where the macrophages would start to engulf and phagocytose all of the necrotic debris and all of the invading microbes and destroy. This is the classical pathway where the macrophages would destroy all of the or most of the microbes causing the inflammation and get rid of all the necrotic debris to pave the path for healing. Then we have another pathway, and that is the M2 or the alternative macrophage pathway, where now the macrophage would secrete cytokines that stimulate the healing process depending on the nature of our injury. So if the injury is localized to the epithelial layer, we would have healing by regeneration. But if the injury goes deeper than the epithelial layer, we would now have healing by fibrosis, where TGF-beta is secreted, and that leads to the recruitment of fibroblasts that secrete fibrin and stimulate healing by fibrosis. Now let's look at what we have here. We have a normal tissue comprised of epithelial cells, and we have the underlying tissue where we have resident macrophages that detect the damage. Okay, this normal tissue may undergo either one of two types of injury. We can have mild superficial injury, as you see here. This mild, you see, I drew for you a yellow line to separate the two stages, the two layers, the epithelial layer and the underlying tissue, which separated by the yellow line. So when we look here, we see that the mild superficial injury is above the yellow line that separates between the epithelial layer and the superficial layer and the underlying tissue. And that is a mild superficial injury. While the severe injury, you see that the damage is so deep that it traverses and crosses the yellow line, the yellow boundary that separates between the superficial layer and the underlying tissue. And you see it extends deep into the underlying tissue. And what you see here is that the macrophages that are in the underlying tissue will stimulate the epithelium to regenerate. When the epithelium regenerates, you see we go right back into normal tissue again, just like here, normal tissue. Why? Because the remnant, the remaining of these epithelium would regenerate to build and remake those cells that were damaged in the superficial layer. Okay, and we have stem cells. So regeneration happens either by neighboring cells proliferating to cover and remake those cells that were damaged. And we also have progenitor stem cells, tissue stem cells, that participate in regeneration. However, in the severe injury, the injury is so deep that the epithelial layers can no longer proliferate, or can no longer proliferate fully. So we don't have the epithelial cells doing an active role here, or the main role, or stem cells. The stem cells don't participate in the healing of severe injury that goes deeper into the underlying tissue. But what we have is we have fibroblasts. These epithelial cells could participate into about 20% in the whole healing process. But the main type of the main cells that participate in the healing, they are the fibroblasts. They are recruited to the site of the tissue injury, and they would start to deposit collagen and deposit scar tissue and remodel that tissue with their metalloproteases, and now we have scar formation. Healing by regeneration is also called primary union. Primary union. Also known as healing by first intention. These are synonymous words. However, scar formation is called secondary union. And also known as healing by second intention. Okay? Now, let's see what we have here. This is now an in-depth look at this. Healing by second intention, or secondary union, or scar formation. So this is the epithelial layer, and this is the underlying tissue. If the injury must elicit scar formation, it must go beneath the underlying tissue. And this is not the eye of Horus. This is these are the fibroblasts. They are immediately recruited to the site of the injury. The first step is the formation of a hemostatic plug. So there is a coagulation in order to prevent the loss of blood, and a thrombus must form. So the first step is the formation of a stable platelet plug. That's why you see these platelets in green, and you have these neutrophils in blue, and in orange we have the macrophages. The next stage is, you see these epithelial cells, I have them here in the yellow. In the first stage, they are away from the site of the injury. However, in the next stage, you see that the macrophages have finished, they are through with their defense mechanisms. The neutrophils are done. The platelets are stabilized. Now you see these blue epithelial cells beginning to move into, to differentiate and to proliferate, beginning to proliferate, that 20% I talked about, beginning to proliferate and start to move into that area that was injured in order to rebuild it. And then we see that in the end, there's a mixture between these epithelial cells proliferating successfully to cover the edges, not the center, the edges. And these fibroblasts would secrete their TGF beta that cause the macrophages would secrete TGF beta that causes the fibroblast to deposit that collagen, and it deposits a form of collagen that is called collagen type 3. So it's a little bit weaker for the initial stages, but in the end the collagen is replaced with collagen 1. Collagen 3 is replaced with collagen 1 that is more tensile, is strong, and then in the end these fibroblasts will secrete metalloproteases that damage and cause a more resilient and cause the remodeling. So remodeling is in the end where we have collagen that is more tensile, and the connective tissue, the extracellular matrix, is now remodeled in a way that is resilient and tensile. So let me just show you these diagrams closer. So let's look at what we have here. So we have normal tissue that is of two layers, the epithelial layer and the underlying tissue. And then there is an injury that is localized to one layer that is called the mild superficial injury. And then we have a severe injury that goes deep into the underlying tissue. And you see, once the injury is deeper into the underlying tissue, macrophages are recruited as we talked, and a hemostatic plug is formed, platelets called a thrombus, and the severe injury heals by secondary union, the scar formation, where fibroblasts are recruited and they deposit collagen and remodel that collagen with their metalloproteases and replace collagen 3 with collagen type 1 that is more resilient and more tensile. And the mild superficial injury is heals by primary union or first intention and regeneration, where nearby and adjacent epithelial cells begin to proliferate to cover for that damaged layer, as long as it did not go deeper into the underlying tissue. And we have stem cells, tissue stem cells, that participate in the healing process. Now let's look in depth at what we have here when it comes to healing by fibrosis. The first step is the actual formation of a stable platelet plug, where we have our platelets and we have our neutrophils and we have our macrophages. And you see the damage goes deep beyond the deep into the underlying tissue. And you see these are the hair follicles, and the injury is so deep. Then after inflammation takes place, and these macrophages engulf all the necrotic debris and the infective agents, what happens is we move to the next stage, where the epithelial cells would start to build on the edges from this side and from the other side, as you see here. And in the center you would have these fibroblasts recruited to dump all of their collagen type 3. And in the last stage, the remodeling, type 3 collagen is replaced by type 1, which is more tensile, more resilient. And now we have the remodeling of that tissue that was injured, and this is the successful scar formation and secondary union, or healing by fibrosis, or healing by secondary intention. If you have any questions, leave it down there, and let's talk about it. Thank you very much. Thank you very much. Thank you very much, and I'll see you in our next video.